5.3.2b. This problem is going to combine all of the types of functions that we know, along with some addition and subtraction and constant multiple rules. So again, it's going to mix everything up, and you just have to practice it a lot to really get the hang of it. The addition and subtraction rules basically just say go left to right. If you have a plus or a minus in between some functions, you just take the derivative of the first one, and then if it's a plus, you put a plus. If it's a minus, you put a minus. And then you do the derivative of the next one, and then if it's a plus, you put a plus. If it's a minus, you put a minus, and you keep going like that. So just go left to right, take your derivatives, each term separately. Okay, so I'm going to do that on this problem. I'm seeing 11e to the s cubed. All right, I know the 11 is a constant multiple rule. It says that if you have a number that's multiplied by a function, the derivative is that same number times the derivative of the function. So I know my answer is going to have an 11 in it. And then I take the derivative of e to the stuff. Okay, now that's a chain rule. E to the stuff, right? The derivative would be the derivative of the outside times the derivative of the inside. The chain rule says to do the derivative of the outside times the derivative of the inside. So for 11e to the stuff, I'm going to start by going, hey, it's 11e to the same stuff, right? Because the outer layer is going to be e to a power. And the derivative of e to the power is e to the power. Now I multiply by the derivative of the inside. The inside is s to the third, and the derivative of s to the third is 3s to the second. Okay, so there's my derivative of the first term. Next I saw a minus, and then 2 times something. The derivative is going to be 2 times the derivative of e to the s, and the derivative of e to the s is e to the s. Then I see a plus, so I put a plus. And I see 7 times some stuff, right? So 7 times, how do we do the derivative of natural log of something? Well, it's 1 over the something, right? So it's going to be times 1 over 4s. And then, last but not least, I have the derivative of 4s. The derivative of 4 times s, that's like your mx problem. Your mx, the derivative of mx is m, right? So it's just 4. Okay, so there's all the pieces, right? 11e to the s cubed times 3s squared, and then I did the minus. Then the derivative of 2e to the s turned out to just be 2e to the s. And then the derivative of 7 natural log of 4s is 7 times 1 over 4s, and then times 4. Okay, so the 4's right here will cancel, right? There's a 4 and a 4 on the top, 4 on the bottom. Those cancel. And I can clean this up a little bit more, right, and just turn it into 3 times 11 is 33. We can move the s squared in front. It's not really necessary. I can put it in the back behind the e to the s cubed, but either way is fine. And then I've got 33s squared e to the s cubed minus 2e to the s plus, after I cancel the 4's, I can write the 7 on the top of the fraction, so I have 7 over s. And that should be enough to give it to me. Let's see, so that is going to be choice. Take a look at all the choices. The only one that's got all the right pieces, right, is choice A.